صل على محمد وعلى آل محمد وبارك وسلم. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. Now today our question is that we have to make a Proteus and its Atmel Studio code in which we will show the interrupt 0, 1, 2 in our Proteus. So first of all we will write our name. Now we have to select the microcontroller, as basically we are using the 2560. So here the microprocessor IC, this is basically the ATmega2560, and now we will choose the LCD, sorry. So it's basically LM0165 16/2 alphanumeric. We will attach here. I will zoom it so it will be clear to you. Now we have to select the push buttons. And also we have to select ground. So we will attach the ground of these push buttons together, and with the PD0 the first push button will be attached, and to the PD1 because it's basically the interrupt 1, 2, interrupt 0, 1, 2. And now we will start this as it's T4. So we will connect it to the port C, to the PC4. Now its T5 will connect to the PC5, and the PC6 will connect to the D6, and D7 will connect to the PC7. We will choose the ground as with VSS will be at the ground, and VEE will be with the ground, and RW will also to the ground, and we will give the power at VDD, and RS4 will connect to the PC0 while E will connect to the PC1. So that's all the connections. And now we will check the Atmel Studio code and we will coordinate, and after that we will show the output here, that what the LCD will show here. So basically now we will try to write the code in Atmel Studio. First of all we will select the new project, GCC executable project, and we will write the code in C. I will change its name. I will press the OK, and the first it will proceed. But we have to choose the device, which microcontroller we are using. Basically we are using at ATmega2560. So I will choose ATmega, and here we will choose 2560. I'll select it. So now we will paste the code here. So we will paste the code here. So this is the code. Now we will explain this code. As first of all, the question was that we have to print, or we have to show the interrupt, that which interrupt is triggered, whether it is 0, 1 or 2. So we will start here from the beginning. I will zoom it. So first of all, this is the define FCPU, which is basically the header files. These are the header files, which you consider that it's 16 MHz frequency, and then it is for input output registers, so we can achieve, or we can write in the code the ports, TDR or pins. Now this is the new term which we are using in this, which is interrupt.h. It is basically for the interrupt, or the which are we are using interrupt 0, 1 or 2, and this is for delay. So for delay functions like how many seconds you are giving delay. Now these are the LCD connections. So we have defined LCD connection, that which is connected to port C. I will also show you, or in the previous video I have shown the Proteus, which we have connected it to the C port, and this is for the RS. What RS mean? RS mean register select, and EN means enable. So these are the LED pins which are connected to the microcontroller. And now these are the function prototypes, basically function declarations. We are basically sending command to LCD, and then we are sending data to the characters. Then we are initializing LCD, and this is for display string, and at the end we are clearing the LCD. Now we will go for the LCD functions, for the command and for the data function. So in the first line we are basically sending higher 4 bits of command, basically a 0xF0 or the 0F, which is basically mask upper nibble, and basically it will keep the lower bits safe. After done this line, that LCD port and is left shift operator we have used, it is basically for the command mode. If RS is equal to 0, it will in the command mode, and if it will be delay and all that stuff. We will go to the LCD. Basically it will send the lower 4 bits data and tell the LCD to read data in the command mode. Now if we go to the next line, which is basically the LCD data functions, in the first line we have initializes the LCD, that we have make the port C output, then LCD power up for the delay, and then we, and in this line in which we have make it to set the 4-bit mode, and then this is the 2-line LCD. Basically these are only for the font size and the increment cursor. So if you don't write it, that's not a big problem, the code will run. But it's for that the code in the Proteus it will look nice, so that's why we have used it. Now these are the display string, that how the LCD will. This is basically a while loop in which it will the loop will start until string ends, and it will send each character in it. Now this we have used the LCD clear. Now what we have basically using, these are the interrupts. INT, so there are 3 interrupts, INT 0, 1 and 2, which are on the PD0, 1, 2 pins in the microcontroller. So basically what is the meaning of ISR? It is basically the interrupt service routine for INT 0. and it is and in the next line, which is both INT0 clear and the string INT0 triggered. Basically, when INT0, the interrupt 0 occurs, it will display the message on the LCD INT0 triggered. And after that, if we push the second button, it will show the INT1 triggered, and afterwards how the previous example I have done, the INT2 will be triggered. After that, we will go to our main function, in which we are calling the inputs and outputs. Basically, we have this is the LCD, initializes LCD. We have set these inputs, and these are the basically pull-up resistors and external interrupts. We are using external interrupts basically. To enable it, we will use the INT0, 1 and 2, so that it will directly go to the microcontroller. After that, we are basically, these are the setting, we are setting falling edge triggered, so that it will, basically what is meant by falling edge, that when we will press the button, so it will use the pull-up resistors, or it will fall the edge. So after that, we have enabled the global interrupt. First of all, the LCD will show waiting. Afterwards, the main the while loop will continue, and it will check that which falling edge is triggered. That if it is INT0, it will show on the LED INT0 triggered. Afterwards, if push button, the second push button is triggered, or we have pressed the second push button, it will show the next. So we will build, this is all the code, and we will now build the solution. So we will, basically we are using LCD, so we will also copy this LCD file. We will paste it here, and now we will go to this and this. Here we will add existing item. Now we will check it. This is the LCD file, this is the main.c. Now we will again build the solution. So the whole solution has been built up. Now we will debug it. So here we will choose the corrected tool, which is simulator. Again we will debug it. So it has been debugged. So it has also the IO ports and the memory, but here we will show the output. So I will save it, and now in the Proteus we will paste here the main file of this. We will go to the Atmel Studio 7, and here we have this file. So this is the X file. We will check as it is working or not. So alhamdulillah, it is working. Now this is waiting. If we push the first button, it will show INT0 triggered. If I will choose the second button, it will, and if I press the third push button, it will send a message to the LED that you should show INT2 triggered. So that's all we have seen the Proteus and the Atmel Studio code. Thank you so much.